Hello everyone. This video we are going to see linked list, insert and node. We are given one linked list and one node and one position. We have to insert this node to this linked list with the given position. Okay. There are several scenarios involved in this. Inserting a position at a position. You can insert at the front, you can insert it in the empty linked list, you can insert it at the middle, and you can insert it even in the end. So we'll cover all of these scenarios in one code itself. Okay, first we'll take a look how do we insert at front and how do we insert that in the empty list. Okay, here we can expect one data and position. First I have to check after creating the linked list in this line number 2. First we have to create two pointers called a current and a previous. We'll make use of these pointers in the upcoming code. So we create the two pointers and a linked list node called n. The n stands for new node. So I've given new linked list node and passed the data. Okay, first I have to check whether my node is empty or my head or tail is null. So head itself is null, means we cannot expect for tail. So what I do is, if it is an empty list, we have to give this new node to that list and we have to assign this head and tail to this node. That's what we are doing in these two lines. First we have to check whether this head is null. So head itself null means we don't need to check tail. So and head and tail will be equals to this new node and we can return. So we'll not have any data in this list to execute. Okay, next we move to the front. Move to the front means here we are given this node. First we have to keep this node and we have to make this nodes next to the remaining nodes. Okay, what I going to check is my position equals to 0. Then that time we already have this node in this line, list node n equal to new list node. So we have this node and our new nodes next, which means n's next is nothing but here the current node. Here you have given previous and current pointers. Current pointer first initially will stand at the head. So this current pointers, here this line satisfies us n's next should be current. And once I assign to this point head next to this one, I need to switch my head to the first one because this is a second node, this can't be a head. So what I do is head should be my new node, so head equals n. Okay, that's what we are covered in this if portion. Okay, now there are two more scenarios. We can insert the node in the middle and we can insert that node at last. Okay, at last stands for maybe that position exists or may not exist. So it covers both the scenarios. When it is exist, we can just link up. When it is not exist also, you can travel until to the last node and you can add this node at, like an appending operations. So let me bring up this code. Okay, here in the else part, what I have to do to insert this node at position number 2. So here 1 2, after this node, after 1 and 2, you have to insert this node like this. Here you have added and from here you can give. Okay, what makes me to travel until this position? That's what we are going to do. Here else part, this is inserting in the middle and the end. So I'm going to use these three variables called mid, for this mid traversal, I'm going to use this previous, current, and P. Okay, what's my previous is I give my currents back up to this previous and I can move. That's what this job of this previous. And current stands for only the current node, and position variable stands for how long I have to traverse. So that's what this P denotes. So what I do is I have to give my currents backup. So previous equals to current. So that's here we make a backup to the previous and we give my current to current dot next. Initially here it's standing and here it is, the current is 100. So I have to give my previous current to this previous, so it will become 100 and I have to go to the next position. So I take 200 here. So here 200. Okay, which means here it is like this, and I have to reduce my position. So here I repeatedly make this operation, but until what node I have to travel, that's decided by this B. So this B here it is 2, and when it is going here it is 1, and when it is going here it is 0. So I have to stop when it becomes 0. So and when third iteration, you can see this one comes here. So what I'm going to do is my previous next, I have to delink it. Initially it is like this and we don't have a pointer here. So what I'm doing is my previous next, I'm taking this pointer and giving this to n, and this ends next I'm going to give it to the current. This is what I'm going to do. Okay, these two lines are my previous next is n and ends next is current. That's what we have done in this one. Okay, like this, if we are going for the inserting at last, what's the enders? Here you have 20, but there is no 20 nodes at all in this linked list. So here it goes, but see, this is the last scenario will come. Here it is 500 and null. Okay, now we reach this position because while condition we have to give this current, and further we cannot do. So here it is 20, 19, 18, 17, 16. So 16 is there. So at this point of time, you just neglect this P value and you have to check that current is not null. So what you have to do is my previous next is nothing but my new node, and my new node's next is current. Whether it is null or not, you don't need to worry because it is the correct one. And then what you have to do is you are maintaining a tail pointer. So you are checking that ends next is there or not. Tail pointer means after this node it should be null. Here you can see there is no node is there, after that no node is there, so it is null. Here the tail is correct, but here you are checking the nodes next, the new nodes next is null or not. So if it is null, this is supposed to be a tail pointer, so you have to move this tail to this node. So this is what, if ends next is null, so you have to assign the tail equal to this n, so the answer will become perfectly. Okay, now we'll do the same implementation in Visual Studio Code, and we'll run some test cases and I will execute this working fine or not. Okay, here I have necessary importing statements, and here are my public class from public parameters of list node attributes, and here this is my driver functions. This driver class were called linked list, and here's my main function. This one I have appended some of the items and print this. So we'll just run this and see it prints the data. And now we're going to write void insert int data and int position. First we need two pointers called current, which is nothing but head, and previous, which is initialized to null. And I have to create node, so list node star n equals new list node, and here I have to pass my data. Okay, first I have to check my head is null. This is at empty case. You can just give not head. In this case you can give head and tail, both should be equals to this n, and you can return because there's nothing is there after this. Okay, now if my position is 0, which means I'm inserting at the beginning, so position equals to 0, what it is, and if it is in the middle or end, what it is. Okay, by the time its positions equal to 0, ends next equals my current data, and head will become my n. Okay, here at the else part I have to travel to that position, so while current existing and position also is existing, here itself you can decrement it, and you have to give your backup to previous, so previous equals to current, and current equals to current dot next, and when previous next, you have to give pre next equals your new data, and your new data's next is your current, regardless of it's whether null or not, it's there. And then finally you have to tell your tail pointer that ends next is not there, so you can give not of ends next, so that time tail equals n. Okay, and then you can call this after appending, you can x dot insert, you can give 5 at position 2, so right click, run. Here it got inserted, and after this 1 2 and then 5 got inserted. Okay, and next I have inserted, okay, this one I have inserted, and we'll think of this scenario. First I have this node 0, and I'm going to delete this node, and 0, and I'll print it. Let me just run. My 5 got printed, and after this I'll append 5 and 6, so 5 and 6 got printed successfully. And what I do is I x dot insert like 10 comma 100, and after 6 it should insert, because this is position is not at all there, so my 10 got inserted after this 6, whatever the last node is, it's got inserted. And after this also I append some, so 5, not 5, 7, so my tail pointer also is working fine. After this append, I can see that 7 is there. Okay, I hope you understood this problem. This is a bit complicated than the other operations. It's similar to the delete, and hope you understood all of these lines, what does stands for. And thank you for watching this video. We'll meet in the next video.